So, up until this point, I've been talking in general terms, all organisms, how does it work? The focus of this last set of notes is going to be human stuff. How did we get from a monkey to what we are today? Well, humans, of course, evolved from primates. We share a common ancestor, common lineage with the other great apes, the chimpanzees, the gorillas, all of those. But how did we get from those to us? Well, that primate ancestor originally lived in trees. So because it lived in trees, it actually had a few adaptations that were present that we couldn't take advantage of as we evolved to be the modern day human. Those adaptations are, one, binocular vision. Having forward-facing eyes gave us depth perception. When you're living in a tree, this is good because you can judge how far away the branch is that you need to jump to. Well, when we become more modern, if you will, having binocular vision is good from a survival standpoint because we had to become hunters when we left the trees. And so hunters always have forward-facing eyes to find the prey, track the prey, and catch the prey. You have to figure out how far away it is so that the spear you're throwing to hit the animal, you can judge as when you hit the animal and not somewhere else. You know how far to throw it and things like that. So having forward-facing eyes was one key adaptation for us to leave the trees. The second one is what we call grasping hands, also referred to as the opposable thumb. Grasping hands allowed our tree-dwelling ancestors to climb, but they also allow two other things. It's called the precision grip and the power grip. The precision grip is what you're doing right now as you're writing notes. In order to write, you have to be very precise and accurate and make small movements. The power grip is what you use when you're throwing a football or carrying a heavy box or something like that. It's not precise, but you have a lot of strength behind it, a lot of power. So having the opposable thumb gives us the choice between using one or the other depending on the situation. And this allows us to manipulate many different pieces of the environment that other species can't necessarily manipulate. The third adaptation was arthritis. Primates, as a group, have larger brains as a proportion of their body size compared to any other animal. Humans have the largest proportional brains to body size. But our ancestors were already heading in that direction. And that large brain allows us to remember things. It also allows us to use hand-eye coordination. So if you're throwing that spear at the animal, you can aim it at the animal and you can be pretty sure it's not going to hit the tree 50 feet away from the animal that you want it to hit. So we do target. Most of sporting events, like football, baseball, whatever that you played as children, the point of those ultimately is to train hand-eye coordination. And our memory allows us to remember who is who. Where are they in relation to you? Are they family? Are they friends? Are they enemies? That kind of thing. And so we can keep track of a lot more complex social structures than a smaller brain would allow. Question so far? All right. So from the primates, and your textbook is already out of date because of new discoveries, but I'm going to try and stay true to the textbook as much as I can with just FYIs of, hey, this is a new discovery. So that when you study, textbook is not horrible. We think humans evolved in Africa. The reason we think that is because we found most of the fossils that we found of human and humanoid ancestors have been found in Africa. But that's because we were looking in Africa and we weren't looking elsewhere for a while. Recently, very recently, last year, there was a discovery of a new human ancestor that predates this one that I'm about to show you by about 7 million years old, a little bit over, that was found in Turkey. So now the question is, did we actually evolve in Africa, or was it somewhere else? So more questions are being raised. The human line of evolution is the hominin line. This is where we get humanoid, hominid, all of those sorts of things. Hominin refers to species that are at least partially bipedal, which means they can walk on 2 feet. They don't necessarily do it all the time. They might only do it for short periods of time, but they are capable of it. So the earliest fossil that is confirmed to be a hominin, according to your textbook, is about 6 million years old. As I mentioned, we have since discovered a new one that's about 7.2 million years old, so older. This fossil, this is the skull of that fossil. Does that look human to you?
Sort of.
Sort of, maybe, but maybe closer to what other animal? Or type of animal? An ape. Okay, a chimp. This brain is very small relative to the human skull. Human skulls, the back part is much bigger, and of course we don't have the very obvious brow ridges. So this is still an ape, our primate ancestor. It's not really a human, but it's starting to show signs of being human, like the bipedal posture and the bone structures and things like that. They were partially bipedal, not fully. They did spend time on 4 legs. They spent time on 2 legs, depending on what they needed to do. Over time, these guys would have been selected to walk more and more on 2 legs because that frees up the upper arms for other things, for carrying things over distances. And that's what would have driven the evolution of walking on 4 legs to pure bipedalism that we have. Questions so far? Okay. This is our hominin family tree. To kind of put you in the picture. Humans are all the way up here. Neanderthals are our closest cousins. Heidelberg is our first ancestor. So you can think of it as our parent species. After Heidelberg, it becomes a little cloudier. We're not as sure where things fit, but we're pretty sure that Ergaster was the ancestor before. Habilis was the first hominid. Not hominin, but homo hominid. And it was so named because habilis comes from the French word habile, which means dexterous, has dexterity. And we named it that because habilis was the first tool maker. And then for those of you who actually did the evolution lab, Lucy is one of these, Australopithecus afarensis. And there was a news story that hit the news yesterday, which I just posted this morning in your bio, in the news folder, about a fossil of the species, about 90% complete from what I found. That is one of those, it's about 3.6 million years old. It's the earliest complete skeleton of a hominin species found in Africa. Again, that's where we look. These guys, we don't really know where they fit. They're kind of just there. So we haven't figured out the pieces that link them in. And then these are distant cousins that petered out, that went extinct. No, you do not need to memorize that diagram. It's just they put you into picture. Questions so far? All right. So early modern humans. Now, when we talk about modern humans, we're talking about organisms that are indistinguishable from the human that sits in this classroom. Those are modern humans. The earliest known fossils of these are about 300,000 years old, found in West Africa. This genus diverged from the rest of the great apes about 2.5 million years ago. So when the fossil record tells us that we split off from the Australopithecus families. Homo habilis was, of course, as I mentioned, the first species that we know of. It may not have been the the first one we've got data on. Habilis was the first to make tools, and as the fossil record continues, each new species of Homo has more tools and more complicated tools, and so we're starting to make more complicated technology as the species evolve. As an example, Homo habilis, this is the earliest tool that habilis would have used. We know that habilis had to have been making it, A, because it was found with habilis fossils, and because on the rock you may notice these kind of curved markings on the rock. That's something that can only happen through deliberate action of a living organism. It's not something that happens randomly in nature. So habilis had to be the one to make these marks, and they made them in order to make the rock do what they wanted. Then ergaster is slightly newer version. They start differentiating their tools. So here you've got an arrowhead and a spear point. So two different tools depending on what you need to shoot at. And then the Neanderthals had the most complicated tool technology. Each of these are arrowheads. Each one was designed for a different animal. Very precise, very targeted, and very diverse as well. Neanderthals had large brains, larger than ours. Their brains were bigger than ours. They had the most complex tools until Homo sapiens came to be. We actually probably learned quite a bit from the Neanderthals as to how to make very complicated tools. Now, we are pretty certain actually that this interbreeding did happen. Your book, as I mentioned, is out of date and is still on the maybe it happened, but we're pretty sure it did. And this raises the question of, because we bred between the early modern human, the early Homo sapiens, and Neanderthal, which were cousins, are we in fact a hybrid of two different species that did not speciate enough to not be able to reproduce? Or the Neanderthals, are they simply a different breed? We don't know that. We don't have enough information. So there is some question as to whether the Neanderthals are in fact a different species, or are they a different breed, in the sense of today we would have African descent versus European descent, which could be considered different breeds of human. We don't know how far apart the speciation had happened with those. But since we know the breeding did happen, there is some question. Questions? Alright, so let's talk about us. We, as we are, first appeared in Africa about 300,000 years ago. Your book states a time limit of about 200,000. But as I mentioned, we found earlier fossils, so here I'm quoting from the earlier time. After that point, now how we got to be the modern human that we are, there are a couple of questions. Because we know Homo had to leave Africa. That's how we ended up with Chinese and Scandinavians and humans all over the world. Had to leave Africa, assuming that that was in fact the birthplace of humankind, which we are not completely 100% on. And this happened, according to the fossil record, in several different waves. So you had a wave of one species, and then later you would have a different species come out and replace the previous one. And then you would have another one, and then you would have another one. And the most recent one, we're not really sure which species comprised the wave. We didn't know if it was Homo erectus, which was one of our immediate ancestors, or if it was our species as is. The fossil record on this time scale, it doesn't give us detail. We're too blown up and it's pixelated and we can't see what actually happened. Okay? Which means there are two possible explanations for how humans took over the world as replacement. The second one is the multi-regional hypothesis. I'll talk about each of those in a little more detail. But are there any questions right now? So the African replacement hypothesis is what it sounds like. Something replaced something else from Africa. So in this case, what the proponents of this hypothesis say is that Homo sapiens emerged in Africa. That's where we evolved from our parent species, Homo erectus. And Homo erectus had already left. So Homo sapiens, there was a small population that was cut off from the rest of Homo erectus that eventually evolved into Homo sapiens. And then Homo sapiens was so good at what it had to do that it spread outward, following the Homo erectus. And it outcompeted the Homo erectus because Homo sapiens was better. And therefore, the Homo erectus went extinct simply because Homo sapiens was better, outcompeted, and drove them to extinction. That's question number one. That's hypothesis number one. Hypothesis number two is a little bit different. So we came to be in Africa, we followed the others, we replaced the others. That's the gist of African replacement. Phone away, please. Thank you. The second one is a multi-regional. In this case, Homo erectus left, but there is no break between the populations. Gene flow still happens between the populations. So there are no differences. The populations don't start doing allopatric speciation. Instead, because there is gene flow, because all of these populations breed together, this hypothesis says that the Homo erectus, over time, the entire species evolved into Homo sapiens instead of just the African population. Now, this also has issues because you start asking, well, what about the Neanderthals? Neanderthals were just in Europe, things like that. Which I'm going to get to. There are several problems here that your book does not know about because we found out about them after the book was published. So, and any questions? All right. So there is a problem with both of these. And that is that through genetic analysis of our genome in multiple different populations of humans, we looked at Europeans, we looked at Africans, we looked at Eastern and Western Asians, we looked at Australians, Filipinos, Aborigines, and certain Native Americans. All of those indicate that we have DNA in the species that came from something that is not Homo sapiens, that is not us. Couple examples. We have Neanderthal DNA in our species. Anyone who is of Caucasian European descent and of Western Asian descent has Neanderthal DNA. So if your ancestors are from somewhere in Europe, up to about Ukraine and Mongolia, well, you've got Neanderthal DNA. This DNA is almost exclusively related to the immune system. It's only about 2 to 4% depending on your genetic ancestry. All of it almost has to do with the immune system. It makes our immune systems more efficient for those of us who have it. Natural selection. If you have it, you're better at surviving. You don't get sick as much. But this DNA also is responsible for making Caucasians more at risk for developing certain types of cardiovascular disease. So better immune system also means sicker as far as cardiovascular systems go. So pluses and minuses. But the only way we could have this Neanderthal DNA in those populations is if our modern human ancestors interbred with Neanderthals. Which is why I say we know this now, and it's not a may have happened, it's a we know happened. Another example, Denisovans, H. denisova, is a group of fossils that we found in the far north of Asia, up in southern Siberia. This DNA is not localized to a single set of characteristics. It's much less correlated in the populations that have it. You have Denisovan DNA if you are of Eastern European, so Ukrainian, Polish, Russian descent. Most Asians have Denisovan DNA, so do Filipinos and Aborigines. Those all have Denisovans. Which means if you are of Central or Eastern European descent, Ukrainian, Polish, that area, you likely have both Denisovan and Neanderthal DNA within your genome. The Denisovans are believed to have been a different species, however, but there was breeding happening there, producing some kind of hybridization. And this is not enough. Right? There is, it's also in certain groups of Native Americans, but we don't have enough data on those to know which groups exactly. But there's also something else. From tracking and matching genetic sequences between all the different populations of human, we found sequences in certain groups that came from somewhere, and we don't know what that source was. So the people of Southeastern Asian descent, they have DNA that doesn't match DNA from any other population of human. It came from another species entirely, and we don't know what that species was. So biotech is answering some questions, but it's raising a whole slew of others. And so from this, we know, so Asian, Native American, again, not enough data for that. But from this, we also know that Denisovans and Neanderthals interbred because we found some fossils with sequences from both species there in the DNA record. So a lot of mixing and matching and breeding with others not of your group in our ancestry. There's a lot of, if you'll pardon the term, bastardization in the human family tree. A lot of babies born on the wrong side of the blanket, if you will, from a species standpoint. And so this makes things much more complicated. And what it implies to me, and this point is my personal opinion, right, which some people in the scientific community agree with and others don't. With that caveat, because only those of truly pure African descent can be considered pure Homo sapiens in that sense of the term. So if you want to be superior, that's a reason to be superior. And by pure, I mean absolutely no one from any other population, which in this day and age is very difficult to find. But this means, or indicates, at least to me, that possibly both hypotheses are correct. That Homo erectus left Africa. There was the population in Africa that started doing its own thing. And then you had a population of Homo erectus in Europe that started doing its own thing and becoming Neanderthals. You had a population in Asia that was becoming the Denisovans. You had a population in Southeast Asia that was becoming this other species that we don't know enough to even name it. And yet they weren't different enough to prevent breeding between those different groups. And so perhaps we have both the group in Africa that was spreading out and wiping out Homo erectus as it went. And at the same time, you had these different populations that were still breeding. So to me, that implies both hypotheses are correct. That it was very much a mix and a mess. Now this slide is not testable material because a lot of it is not foolproof, if you will. But interesting food for thought there. Alright, back to testable material. Now you might ask, well, how do we know humans evolved? There are several indications here. First, in the past, I'm going to pick one trait to discuss for past evolution, and that's the large brain, because that's the thing that really differentiates modern humans from any other Homo group, and any other hominid group, and any other ape, if you will. The large brains are what makes us truly different in that sense. Now, these first appear in the fossil record about 2 million years after that hominid fossil that I showed at the beginning of class. That skull was 6 million years ago. The large brain starts appearing 4 million years ago. And that's where we really see the brain, the back part, actually getting noticeably bigger relative to the skull. This is actually a pretty sudden change in the fossil record. It went from a dinky little monkey skull to a noticeable bigger skull, which is not something that happened gradually. So, as always, question, we want to try to answer it. And there are a few possible explanations, and the true reason is probably a combination of these. The first one is, about 4 million years ago, the Homo species had left the trees, and we needed to survive. So our food source became meat. Well, how do you get, there are two ways of getting meat. Which is the one you prefer? And I don't mean going to the store and buying it. You can, what are the two options? Let's start with those. Sam?
I like shooting.
Hunt it, yes. Hunting it is one option. Anyone know what the second option is? Goes along with hunting. You capture it, you catch it, you kill it somehow. What's the other option? What do turkey vultures do? Scavenge it. So you can either kill it yourself, or you can find it already dead and eat it. Alright? Which of those would you prefer to do? Kill it yourself. Alright? And our ancestors were not that different. Okay? They have an option, they prefer to kill it than find something already a couple days old and dead that maybe doesn't taste very good. Not to mention the whole gross issue. So, to find and hunt meat, you work much more effectively if you're in a group as opposed to having to do it all by yourself. So, cooperation. If you're hunting and in your hunting group, you remember that yesterday, Jagger stepped on a branch and broke it and scared the animal away. So you didn't eat that day. Well, how are you going to fix that problem? Well, you don't take Jagger. Okay. Or, if you have to take Jagger, because Jagger needs to feed his family, and he's not going to feed his family if he doesn't hunt, well, we've got to figure out, okay, how do we stop Jagger from stepping on the branch and scaring away the animal? So you gotta cooperate. Maybe it would be better to put Jagger in the tree and have him ambush the animal. You've gotta be able to cooperate, to figure out workarounds, to figure out who does the best job and where to put that person. Cooperation takes a lot of brain power. So you've got a lot of things that you've got to keep track of. This also leads to very complicated social structures. Typically, the males are the hunters, the females are the gatherers. That's the kind of society we're talking about. Well, if the male wants to reproduce, he's got to convince a female to take him. One of the easy ways of doing that in very primitive societies is, here, I have meat, have my babies. Because I can feed you and I can feed babies. And so, everyone in the group starts remembering, okay, Jagger is a horrible hunter, Zach is a good hunter. Zach is going to be better, so I want to do good things for Zach so he will help me out. Or figuring out who is alpha, who is second, who is third, who has power, who does not. You've got to keep track of that when you're in a social group. The bigger your brain, the more of those relationships you can keep track of, the longer you can remember what happened in the past. This is the basis for all of the social interactions that you have today with your friendships, your grudges, your sort of hi, nodding acquaintance. Yeah, I've seen you before, you're in my class, but I have no idea who you are, kind of thing. And it boils down to one very basic question, which is who gets the food? If you're alpha dog, you're going to get most of the food. If you're a female, you're going to get more because the males are trying to keep you sweet. But if you're the bottom of the heap, the guy who always messes up, you're not going to get very much because you don't provide a necessary resource to the rest of the group. So it's originally probably all based on who got the food. And then from there it grew into the very complicated structures that we have today. Another explanation is about 4 million years ago is where we start seeing evidence of deliberate cook fires along with the Homo fossils. What would cooking meat do? Anyone know? Why do we cook our food? So we don't die. Actually, no, because at the time they had a very active and efficient appendix. And the whole point of the appendix is you can eat raw meat and it won't make you sick.
Can you keep cooked food longer?
Okay, part of it is preservation, but you can also keep cooked food by or keep raw meat by drying it. That's one of the ways in which you make jerky. But cooking it is more efficient at preserving it, so that would be one option.
It's more digestible.
It's more digestible. Okay, if you cook it, you're already starting to denature it. And denatured protein is a lot easier to digest than complete and functional protein. So when you cook it, it's easier to digest. You don't have to spend as much body energy to digest this food and get the pieces out that you need as you would with raw meat. Cooked is easier to use. It's more efficient to use. Which means you start cooking food and your energy budget starts going up. Yes, I'm going back to the whole cells thing. Which means because you took less energy to digest the food, you've got more nutrients that you paid less for. This is the whole idea behind sales, that you get more for your money. Which means you've got more energy, money, and more nutrients that you can use, which means you can spend more of that energy building more complicated brain structures and developing more complicated brain chemistry. So the more complicated the brain gets, the more efficient we get at getting things like food and making it easy to digest and all of that. And it turns into a positive feedback cycle. Bigger brain means more food. More food means bigger brain. And then you keep going through until you get the very complicated brains we have today. Questions on that? Alright. Now, evolution in humans did not just happen 4 million years ago. It also has happened in the very recent past. So some examples of that. We've used biotech to identify genes that have changed in the last 10, 20,000 years. So very, very recent. For example, milk drinkers. How many of you, either you yourself or you know somebody who is lactose intolerant? Most of us know somebody like that. Are there more lactose intolerant people or lactose tolerant people? As in, more people who can drink milk at your age or more who cannot? More people who can. This is because about 10,000 years ago, during the agricultural revolution, you start domesticating animals. And so you start getting this resource of, wait, that cow has milk. If we drink the milk, we've got another source of nutrients that we don't really have to work for because we've got to keep the cow anyway. And so you start getting people who, by random mutation, don't turn off the genes that allow them to drink milk, and then they produce more kids because they've got the extra nutrients, and that has very quickly, in fact, taken over the human population because of how much extra nutrient value that milk gave in addition to the rest of the diet. Another one that is modern is losing the wisdom teeth. Up until about 100 years ago, everybody would be born with 4 extra teeth that we call the wisdom teeth that came in at about 15, 16, 17 years old. They came in to replace teeth lost in childhood. Well, in the past 50 years, what has happened in the medical field for humans?
Dental care?
Dental care. What that means is, in fact, quickly, really quickly, we are losing wisdom teeth. There are more and more babies who are being born with fewer than 4 or no wisdom teeth at all. I was one of the lucky ones who was born with 0. I never had to get the surgery. My brother was born with 3. He did. He looked like a mushroom for 3 days. But more and more children are being born with less than 4 because our dental care means we don't need the replacement teeth because we don't use them in childhood, and therefore the extra energy necessary to make those 4 replacement teeth, get rid of them, use the energy for something else. It's a very strong, actually, change that's been happening in the last about a century, actually, is when that's been happening. Another one is disease resistance. Our immune systems are getting more efficient at fighting off diseases and better at it. So that's pretty self-explanatory. Another one that was surprising. Our brains are getting smaller. Over the last 10,000 years or so, we've lost about a tennis ball size amount of brain material. Okay, now it's not an actual tennis ball size, it's that amount that we've lost from throughout the brain. Why would our brains be getting smaller when we're making you guys do things like algebra and calculus more and more? Our brains are getting more efficient. The wiring is getting better, so we need less brain matter to do more complicated things because our cells are getting better at doing it. So we make you do all that complicated math because we think you need it. Not that you can't do it, so we set you up for failure. We don't do that. Another one is, in fact, blue eyes. The original eye color for humans is brown. About 20,000 years ago, there was a population on the shores of the Dead Sea where there was the blue-eye mutation first appeared. And there was actually a study on this a few years ago, which I found kind of interesting, where they tested brown-eyed males and females and blue-eyed males and females, and all those people were asked to do was to rate how attracted they were to members of the opposite sex. That was all they were asked to do was, are you sexually attracted, yes or no, period. And what the researchers found was that females, regardless of eye color, there was no correlation between brown and blue-eyed males. Well, this kind of makes sense. If a female gives birth to a child, to a baby, is that baby yours? That girl's? Well, yeah. Okay, trust me, that baby's yours. Brown-eyed males had no preference between blue-eyed or brown-eyed females. But blue-eyed males were the interesting one. They were the only ones that showed a preference, and they were very definitely preferred blue-eyed females, which also makes sense from an evolutionary standpoint, because if you're a male and your female gives birth to a baby and tells you that that child is yours, do you know for sure that that child is yours? Or do you have to take it on trust? Come on, guys, be honest.
You better hope
You better hope it's yours. Yeah, you're taking it on trust because you do not know for sure, because that thing did not come out of you, it came out of the female. So, males have to take it on trust. Now, if you're in a good relationship, that trust is taken as read, and duh, you can trust her. She says it's yours, it's yours. But 20,000 years ago, there was no way of knowing for sure, until we got the blue-eyed mutation. Blue eyes and brown eyes, which one is recessive? Blue eyes. If you're a blue-eyed male, and you have a child with a blue-eyed female, and that child has brown eyes, is that child yours? No. Blue eyes were the very first fraternity test. Because that was the first point at which a male, a human male, could look at that child immediately and say yes or no, is that mine? And so females have no preference because, duh, you know. Males do because males were the one to feed that family. And they weren't going to feed a child that wasn't theirs. They would kick the cheating woman out rather than feed her and her bastard child. Because you want to make sure that your genes survive and you're not going to help somebody else's genes survive. So I found that interesting to realize. Makes you wonder what makes you attracted to somebody. Another one that's much more, not as modern as a wisdom teeth, but still very modern, and actually pretty extreme for evolution, for a natural selection, is the Tibetans. Where is Tibet?
Right in the Himalayas.
It's in the Himalayas. It's in the foothills of the Himalayas, and it is the highest point at which humans have set up a permanent establishment. The Tibetan plateau was colonized about 3,000 years ago. And in those 3,000 years, there have been a number of significant changes in 20 genes in the human genome. These 20 genes all help a high altitude survival. All help you survive in the very thin air at that high of an altitude. And what was especially surprising, all 20 of these are in children. They help children and babies survive at the high altitude. Why would that be a significant selection factor? To have children survive.
Because then those children can grow up and have their own children.
Right, reproduction. If you have genes, that means your kids survive to adulthood. Those are the kids that are going to reproduce. This is actually, as far as quick changes, this is huge. It made a big splash when it was published a few years ago in the scientific community, because it shows how quickly natural selection can work in certain situations. These 20 genes in the Tibetans are very different from those 20 genes in the standard human population at this point. Not enough to make them a different species, but